Hey everybody, welcome back to another fun and exciting Algebra 2 class. What we're going to be doing today is just kind of continuing along with logarithmic functions. Last class we kind of learned a little bit about them. We learned how to identify them, how to move back and forth between exponential and logarithmic. Today what we're going to do is on page 344, page 344. And we're going to be talking about the properties of logarithms. The properties, just like we had properties of algebra that we learned, commutative property, distributive property, associative property, different properties, inverse property, identity property, lots of different properties. Same thing, and then we learned more when we talked about exponents. We learned the power rules and different things like that, different properties of math, algebra. Well, same as those different properties, we have to learn different properties of logarithms. If you look down here at the screen, I have written down the properties of the logarithm. Properties of the logarithm, and we're going to learn 4 different properties of the logarithm. They are also on page 345 if you want to follow along in your book. 345, it's table A in your book. That's anytime in your book that you see the word table and then A, table B, table C, that table's important. All right, you really need to know that table. So let's take a look at these things. The product property. What does that mean? Well, what's product mean? It means we're multiplying. So if you look at this example that's right here, they are multiplying UV together. UV. So the log base, whatever the base is, it could be base 10. Remember, that's the common log. It could be base whatever, base 6, base 12. We don't know how to do those bases. It could be the natural log with Euler's number as the base. If you look there, it has both. So it has a base with a b, and then it shows you how to do it with a natural logarithm. And really, it's all the same. There's no difference. So I'm just going to show you the regular one, and then when we do the practice, we'll practice with some of the natural log. But everything's the same, so there's no change. So we'll just kind of practice with one, and then we'll add just a little bit of the natural log after we do some of these practice ones. All right, so how do we do this? How do we solve this? Well, it's not really solving necessarily as much as it's simplifying. Okay. What the book calls it is expanding it. Why do we need to expand it? Well, we need to be able to solve it. And in the next lesson, we're going to learn how to solve them. So this lesson, we're learning how to expand them. Next lesson, we'll learn how to solve them. Well, here's the expansion of this. Here's the rule, the product rule. Just like with exponents, remember, when we're multiplying exponents, so if we have x squared times x cubed, what is the answer? X to the 5th, because we add, there we go, we add the exponents, right? 3 plus 2 equals 5. We don't multiply. Okay, so even though it's product, even though we're multiplying here, we don't multiply because we're dealing with exponents. Same thing in the logarithms. So here's what you're going to get. You're going to expand this. And so here's what it looks like. It looks like log base of u plus the log base of v. And then what you would do, again, because your calculator can't necessarily handle it like this. Let's say that u equals 6 and v equals 7. Well, you wouldn't just put 6 times 7 right there. If you put 6 times 7 right there, then you've messed up. What you have to do in your calculator to get it to solve, to get the correct answer, is you would have to do log b times 6 plus log b times 7. I think it was 6 and 7 that I said. So, that's the way that you have to solve this. And we'll work through this some more as we keep going. But that's the product property. The quotient property. Quotient means division problem or the answer to a division problem. So if we go over here and if I added before, remember when we did exponents? x cubed over x squared. What did we do? We subtracted and we got x1 or x because we subtract. That's how we divide exponents. When we divide exponents, we subtract exponents. Remember, these are just fancy exponent problems. They're just inverse exponential equations. So we're going to solve them the same way. In other words, what are we going to do here? We're going to say the log b of u minus the log, I'll try to be consistent, the log b of v. And then we would just, again, put that in your calculator, put the log u, and then hit minus, and then log v. Now, we do have to do those a little bit different in our calculators to get the right answer. Most calculators will force you to put these in parentheses like this in order to get the correct answer. Okay, so you put this quantity in a parenthesis, and then you hit the minus sign, and then you put that quantity in parentheses, and it will subtract those two things together. The power property. Remember what we did when we had a power to a power? Okay, something like x squared cubed. Remember that? Okay. We distributed or we multiplied and we got x to the 6th. Remember it was x squared times x cubed equals x to the 5th. That's the product property when we add those. Okay? But now we are taking a power to a power. Okay? And so we multiply. So what do you think we do here? You guessed it, we multiply. So what we want to do here is we want to take the n. Now this is important, again, because your calculators can't handle all of this stuff. If you just type it in like this, and then your calculator is going to look at you like, what are you trying to do to me? It's not going to know what to do. So if you'll take this, and when you convert this, when you what's called expand this, you need to move this to the front. All right, so here's what it looks like. That would look like n log b u. I think, let me draw a better u. There you go, okay? So that's the way that we would multiply it. Look, we multiply it by that. Let's just pretend like that's a number for a second. Let's say that u equals 2 and n equals 3. Well, what we would do is we would say 3 log b of 2. And so that is a multiplier. What does that mean? That means that your calculator is going to multiply this. You would first do this part, or you could put this in parentheses in your calculator, and then it would multiply together, and then it would give you your answer based on whatever your numbers are, because the n can change and the u can change, obviously. All right, so those are the basic properties. There is one more called the inverse property. You won't use this one as much, but I do want to show it to you. It's really not that big of a deal, to be honest with you, and you'll see why as we continue through the chapter. But here's what this one says. In other words, if something is an inverse of each other, what does that mean? So 2 over 3. What's the inverse of 2 over 3? Well, it's 3 over 2. What happens when we multiply those two things together? That cancels, and that cancels, and we get 1 every time. When you multiply inverses, you get 1. Well, what happens in this case is when we're dealing with an exponential inverse or a logarithmic inverse, what happens is the answer comes out to be the exponent right there. Okay, the x, whatever your exponent is. It could be, x equals 5, and the answer would come out to 5. What's happening there? Well, it's somewhat complicated in your calculator, but basically what's happening is when you put the log base, and then when you put that exponent, this stuff cancels, and you're just left with your exponent. Okay, and again, it's a little bit more complicated than that, but your calculator is doing all the work. You don't have to do anything. So if you were to put this in, and you can try it, You can call your base whatever you want it to be. Most of your calculators have a way to do this. We're going to learn how to do that a little bit later, but you can put that in and it'll kick out the number that you put there. So, all right. Let's do some of these. Let's just try some that we'll just go back over there. So how do we do this one? Do you remember how to do this is the product. Remember? We're multiplying those together. So what does that look like? What's the expansion of that? We're going to expand that. We're going to get log W plus log Z. That's what we get. Because when we, in exponents and in logarithms, when we multiply, we add. Okay? Now, what's the base on this one? It doesn't have a base, right? So what's the base of that guy? Well, that's a common log because it doesn't have a base. So the base is 10. So don't forget that that common base would be 10. You don't have to write it. You're wasting your time writing it. But I did want to go back over it just to remind you of that. All right, here's another one, log x over w, log x over w. So what do we have here? We have the quotient property going on because we have a division problem. In exponents or in logarithms, what do you do when you have a division problem? You subtract. So we're going to get log x minus log y, log x minus log y. Okay. All right, here's one. I told you we were going to get to some that had the natural log. Here's an ln. That stands for natural log or log natural, if you want to do it backwards. So what's the natural log? Well, that's just a different button on your calculator. You're not solving these anyways, right? You're just expanding these. So what property is going on right there? What do we have? We have an exponent to an exponent, right? We have the power property. So remember what you do is you take that exponent right there and you move it out to the front. So that's going to look like 4 ln z. 4 ln z. All right. And remember, I said that it basically doesn't change just because you're using the natural log. It's the same thing as using log. It's just a different base that you're dealing with. All right, so let's expand this one. This one has a couple multiple different things going on. Let's kind of do each one of them separately and see what this looks like once we expand it. You can do it a couple different ways, but what I would do is I would just kind of break this up into two different problems. So we have the first, remember there's really two things going on. There is the product rule and the power rule. So here's the product rule. X times y. So we want ln x squared plus ln y. Okay? That's the product rule. Now we have to deal with this power rule. Okay? So what do we do with that power rule? What do we do with that guy? Do you remember? That's right. We kick him out to the front right there. So it's 2 ln x plus ln y, and that would be the correct answer right there. And that's expanding logarithms. Expanding logarithms. Let's do one more. This is so much fun, right? I mean, everybody here is having a good time, and so you just want to do more. I know you want to do more, so let's do more. Let's keep going. Let's not stop. It's so much fun. All right, let's just do this last one. You're like, you are weird, dude, because this is not fun. All right, let's do one more. I know you're not having fun. You're ready to go sleep. So let's do this one. What's going on here? I don't remember how to do that. We haven't done one of these yet. Well, this is going to solve out just like it always has. How do we do this? Well, the easiest way to do this is to turn this into, instead of using a square root sign, let's use fractional exponents. Okay, so how do we do that? Do you remember? Remember the index is 2 and that exponent would be 1. So this is going to look like log of x to the what? And you got to remember which one goes where. This exponent stays the numerator and this is the denominator. The index is the denominator, so 1/2. And we're multiplying right here. That's a multiplication, so we change it to plus. We're expanding it. That would be log y to the 3 is the numerator and 2 is the denominator. Now, we still have a problem with this one because, again, we have exponents here, or we have to use the power rule. What do we do with the power rule? We send those guys to the front, okay? So we'd have 1/2 log x plus 3/2 log y. And that would be our final answer right there. Now, again, we can do more with this, especially once we figure out. But if we set it equal to 0, if we make it an equation, if we do different things, we can solve it. But for right now, we don't know what x is and we don't know what y is, so we can't solve it. All we're doing is expanding these. We're taking it from this format right here, and we're expanding it to this format right here. Okay, so pay attention to those rules. Learn those rules. Make sure you know what to do with each one. When you have a power rule, when you have a power, know what to do with the power. That's move it out to the front. When you have a product, when you have a multiplication, make sure you know what to do. You add. When you have a division, when you have a quotient rule, then you would subtract. Okay? There is more in this lesson. I'm going to divide this lesson into 2 parts. So that's the first part of the lesson. If you missed anything in there, that was action-packed. I mean, it wasn't like action, but it was packed with stuff. So if you missed anything, make sure you slide it back there and you rewind it and you figure out what you missed. And then try some of these examples. There's lots of examples there, okay? All right. We'll see you later. Have a good one. Bye-bye.